So today is a special day. We start our first technical session, and I'm really happy to have Aleksandra Przegalinska with us on board. She's the Vice Rector at Kosminski University in Poland. So we have an academic who is sharing with us today what is the Internet of Things and how does it work. And it will not be an academic lecture. We told her this is for teachers and for students. And we have worked with Aleksandra before. She is absolutely amazing, enthusiastic. And I'm quite sure when the students see this video, there is no doubt they will be probably going in a similar path in STEM education and maybe even in similar paths like Aleksandra, who is afterwards joining a NASA conference. So I'm very glad that you gave us the time today before another conference, and we are almost at the same league. So a few words about Aleksandra. She also at Kosminski University leads the AI in Management program. She recently did a research at the Center for Collective Intelligence at the MIT in Boston. She graduated from the New York School for Social Research, and in 2021, just a few months ago, started another short senior research fellowship at the American Institute for Economic Research. So she is interested in the development of new technologies, natural language processing, humanoid artificial intelligence, social robots, and wearable technologies. So who, if not Aleksandra, is telling us and sharing with us what is Internet of Things? Let's look at our objectives and the agenda for today. We first go a little bit into the program timeline just to put us on one common path where we are with our program. Then briefly the learning objectives, a presentation by Professor Przegalinska. Then we do a team exercise, and at the end we have the team presentation by all our groups on that team exercise. So on the program timeline, so as I said, today we are starting our first thematic session. We had 3 thematic sessions behind us on education for sustainable development, and now 5 technical sessions ahead of us with 2 sessions led by Aleksandra, and then 3 other sessions which are really more practical hands-on technical sessions by Science Scope. So Aleksandra is with us today and on Friday. I hope you will not miss this, this occasion. We can go to the next slide. And that is basically, I think we can skip this, but that's just for you to share. We today focus on IoT. On Friday, we will focus on big data and AI. So the whole idea is to give you all a basic knowledge. Some of you are almost expert level, but a number of you also start with this topic for the first time. And with the team exercise, you want to strengthen some team spirit and collaboration. So without further ado, I hand over to Professor Przegalinska, and you have all our attention, Aleksandra, please.
Awesome, great, thank you. I'm going to share my screen, and please do tell me if it's visible, if the presentation is fine. I see that you're nodding your head, so it is visible indeed. It's a pleasure to work again with Leonie and the team, and it's always very nice to have the opportunity to talk about new technologies with people who are invested in education, because essentially that's where the journey with technology should begin. The earlier, the better. So I was nicely presented by Leonie already, so I'm not going to add much more. I'm just going to say that indeed I do work in the field of AI in particular for 10 years now, or maybe a bit longer even. I've been working with MIT, continue to work with the American Institute for Economic Research, and also I will be joining an initiative on the future of work at Harvard in a few months. And my recent interest is mainly in how to facilitate interaction between humans and artificial intelligence-based tools. So how to create tools that do not replace our work, but rather work with us in a synergetic way. And that's something I will also try and share with you on Friday when we will speak about artificial intelligence. But we today also have a very relevant topic, also very relevant for artificial intelligence, actually, and bridging different technologies, different modalities together shows us how this big, let's say, ecosystem of emerging technologies is actually creating new opportunities for us. And surely IoT belongs here, and it's a very important part of this new emerging technological ecosystem. So I want to spend, some time talking to you about my perspective, my take on IoT. It's less of an industrial take. I'm more focusing, let's say, on wearable technologies. Our research team, Human Race at Kosminski University, has been using various sensors and wearable technologies to extract data from human subjects also, and to make our experiments better and to understand how to create better artificial intelligence. But IoT surely is very, very important. So as I started saying, we currently see at least few very powerful technologies, platforms, enablers. AI is one of them. 5G and potentially 6G would be another one. Blockchain would yet be another one. And Internet of Things is definitely crucial here. It's also one of those most important emerging technologies. And for AI in particular, it's very important. And for all kinds of systems that really process data, IoT is extremely important because IoT allows us to extract real-time data, and that's a main difference, right? So apart from the fact that, we have been using various historical data to create, for instance, artificial intelligence systems and models, that we now have this opportunity to create a new layer of context and a new layer of understanding for AI. And that's because we have real-time data coming from industrial sensors, from wearable technologies, from all different types of portable devices that we can see in the medical field and in industries across various sectors. And that's something that IoT really brings to the table. So instead of relying on historical data to model certain processes, we can actually focus on the real-time data. And a great example here, I think, would be, for instance, traffic jams and congestion on the streets. When you think about smart cities, when you think about modeling congestion and informing about congestion on the streets, and also avoiding or preventing congestion on the streets, you actually do need quite often pretty powerful data processing systems. Could be AI-based, could be artificial intelligence system that would be able to kind of steer whatever is happening in the city. But without real-time data, it's not going to do the job very well. It can only rely on historical data and just try to model something, but without really the locality and the context. And this is something that IoT truly provides. And that's why I think, AI will not develop well in the future without IoT. These two seem to be very much intertwined, right? So IoT is obviously, a short version, let's say, of the name Internet of Things. Some people tend to even talk about the Internet of Everything. I don't think we're quite there yet, but we are definitely at the level of the Internet of Things. So all different types of devices, as we said, sensors. It can be anything that has a sensor attached to it. That the sensor can transmit any kind of data that is able to communicate with others, right? So we can talk about furniture, we can talk about different objects in public spaces, we can talk about factories where sensors can provide information about the current situation, can provide information about movement, about localization, and different contextualization possibilities, right? To understand really what's going on. And that will, for instance, in the factories, in particular in the industrial space, play a big role. Because if we, again, have real-time data, we can prevent certain things from crashing and understand better how events might unfold, right? So IoT here is a very important source. And I think currently we see that there are more and more devices out there and objects out there that are becoming important sources of data for us, right? So one important source of data is obviously the internet. We have structured and unstructured data here, textual data, numerical data, all different kinds of data. We obviously have many devices that are connected to the internet and are data transmitters and data providers, such as our smartphones or tablets or computers, but we also have smart devices such as smartwatches that are becoming intrinsically and I think more so now popular, particularly among audiences that wish to train, that wish to focus on their well-being and fitness. Here, those types of trackers are also becoming quite popular. We also have other types of devices that can play a role here, right? We have digital cameras in many different areas, right, that are screening whatever is going on. They're also capable of recognition of objects around them. We have different types of gyroscopes. We have different types of sensors of other kinds that are providing information of what's going on, right? So all of that actually counts as this big network of the Internet of Things that is expanding constantly. And I wanted to show you briefly some interesting devices that belong under this big umbrella of the Internet of Things, but are kind of futuristic, because I think that's quite interesting. We do know about different types of sensors that we have on our devices, cars, bikes, or our own wrists, obviously, but there is an even more, I would say, interesting realm of new devices that transmit even more, I would say, sensitive, or if we may even say intimate kinds of data. So here on the screen, you, for instance, see a portable EEG device. So it's an electroencephalographer that you can wear on your head. As you can see, it's not a wet cap with gel or so, and not the type of medical device that we would be used to when we think about, for instance, different types of EEGs, right, that are, let's say, performed by medical professionals. This is more of a device for end consumers, for users. This device is quite interesting because it connects via Bluetooth with your phone, and it provides very much simplified information about the state of your focus and the state of your concentration, right? And it can even gamify that information. So to show you that, for instance, if the app is turning red, that means that you're less focused and less concentrated on what you should be doing. And when the app is, let's say green, then that means that you're fine and well focused. And obviously that data is pre-processed and sent to you, but that data can also be sent elsewhere, right? And that's like this, I would say, big thing about the Internet of Things. On one hand, its potential, but also perhaps certain ethical aspect of it that should be raised is that it can really source and collect various intimate data and send it to many different places. And we essentially should know where that data lands. So that's just one example of a wearable technology that is perhaps not yet mainstream, but at some point will be. You can see here this app, right? The focus training app, where all that information that essentially is coming from your brain activity is being stored. There are other types of devices that are also collecting similar types of data. This, for instance, is a device that is no longer existing, but I'm sure that it will be replaced by a new type of technology that will attack essentially the same problem. This is a sleeping management mask, right? So it's essentially a sleep facilitator. It's full of different types of sensors. We have the gyroscope here, but we also have the EMG, which is electromyography, right? So that's the type of sensor that allows us to collect information about frowning here, and about, movements of your facial muscles, involuntary movements quite often. And it's an important information about the state of alertness that you are in. Are you sleeping? Are you not? What kind of phase of sleep that is? And, where are you essentially during your sleeping phase? So the people who have constructed this device, it's called NeuroOn. And for some time it was available on the market, and then also won a big crowdfunding campaign on Kickstarter. They were trying to claim that through that information, the information that this device stores, they will be able to advise you better or guide you better through patterns of your sleep and optimize the way you sleep so that you actually feel well rested even after a short type of sleep. And that was like a long journey, as it always is, I think, with many different types of wearable technologies. Not all of them go mainstream. Some of them actually remain in that space of promise and never become really the tools that the mainstream uses. However, when we look at the smartwatches, actually we can see how this evolution went, right? From only some users using them for only certain functionalities, to many people using them to actually understand better what was the pattern of their movement, how many steps they have taken, and whatnot, right? So here is yet another device, and that's something I'm showing, being more cautious. And actually, this is a device we've tested a bit in our lab. And it's a device that allows us to not only track certain parameters of your brain functions, but also actively stimulate them, right? So it's not a passive tracker. In IoT, we essentially have devices that are tracking something, but we can also have trackers or portable devices that are trying to change something in the environment, right? So impact that environment. And it's a completely different category that also requires, I would say, closer attention of, for instance, ethical committees of universities that, or like different types of boards that accept these devices to be widely used. And this device actually at the beginning was a consumer-based device and then turned into a device that was fully medical and only medical, because it was a transdermal stimulator. So it would transdermally through the skin stimulate certain areas of your brain to actually make you feel more energized. And I can tell you that the effect it had, for instance, on me was like a shot of espresso, but it was a very long-lasting effect. So it was a very interesting effect. However, I would not maybe really recommend it to anybody out there because, well, for instance, if you have an undetected epilepsy, then you will be in trouble using that device. And the fact that it was available freely on the market was ethically dubious, at least to my understanding, right? So, but it's just for you to understand that in this vast space of different wearable devices, we can obviously talk about certain sensors that are historically well known, like in factories, but also new types of devices that are just appearing somewhere on the horizon and probably will be used to some extent widely in the future. Here is another device actually that we've been using in our lab quite extensively. More recently, the application of it was to check how people adopt to urban greeneries and green wild spaces in the cities. This is also a wearable technology that is an EEG sensor. And again, very much simplified when you compare it with a cap, right? Like this one. This was the EEG back in the day, right? So it was a big cap, you put it on, it takes hours, right, to put on, and it's very cumbersome because you have to attach everything and whatnot. And this device, on the other hand, is very easy to use because you just put it like this, place it on your forehead, and it is ready to work, and again connects with your Bluetooth on your smartphone and sends out different types of data about the state of your focus, which is the alpha wave essentially in your brain that is responsible for that state of relaxation, but also digesting information, right? Not active learning, not being super active, but also being able to process information from the outer surroundings, as opposed to, for instance, the theta wave, which is a wave of either deep sleep or deep meditation, where you are actually, far away from the reality in front of you. And devices like that can, to some extent, really capture that if they're properly used, and they can have many different applications. So as said, we have actually used this device in one experiment to gather information about whether the state of being bored is a collective state. So we were doing experiments with this device in a classroom setting like this one, but offline. And we would check whether people were kind of experiencing boredom at exactly the same moment. So was it really something that you can, take from others, pick up from others? And indeed, it was the case that it seems like it's a collective sort of phenomenon. So that was interesting. But the other research, very recent, that we've done with that in Warsaw was related to urban greeneries and green spaces that are not regulated, that are wild spaces. For instance, at the Vistula River, you would have many different bushes, and that's not necessarily an area that is a nice park. And we wanted to understand how people feel when they are there. Are they feeling calm or rather more threatened? And that was to actually establish policies about this space so that the city of Warsaw understands better in the future whether it should keep things the way it is or whether it should start to regulate that wild urban greenery. So application of a sensor like that can be very, very fruitful. It doesn't have to be only for the academia or research, but it can also have really an impact, right, on the world. So I think that's interesting. And here you can see actually my first reading from this device, 0% calm, not too good, I guess, not too fruitful. But here, for instance, that was a year later, so that's 2016, and 2017 already many awards and definitely a better reading, right? 400, even more than 400 calm points. So I was actually, through the device, I was guided to try to focus better, right? So the device was kind of also impacting me, but not in the way the previous sensor was, but rather through guiding, through using actually a voice assistant that was supporting me in that process of regaining my state of calmness. So that's, I think, quite interesting. And these are just some examples of devices that we will see definitely coming up, right? So most definitely IoT is becoming richer and bigger. And here you see a description of essentially what IoT is, right? The interconnection via the internet of different computing devices embedded in everyday objects, really, right? And enabling them to send and receive data. And those everyday objects can also be, as we just said, your furniture or pieces of different devices that you have, for instance, in your kitchen. We can imagine that a coffee machine becomes an IoT device because it's connected, for instance, to your alarm clock and knows when you wake up and turns itself on when you're waking up so that your coffee is ready when you enter the kitchen, right? Another example is obviously a garage door that opens up when the car is arriving, right? Because it's well connected to the car as another IoT object. So we can think about these networks in many different ways. And indeed, there is yet another thing that is like very important about IoT, is that IoT is the biggest harvester of big data, right? As I understand, you're speaking about big data during this class quite a lot. Big data has its own characteristics. You need velocity, veracity, variety, and whatnot, those 5 V's of big data, which creates a really big or huge volume of data, which is a great resource, really. And IoT, as we can see, in terms of sources of data, is definitely a big data provider, right? Obviously, not the only provider. There are other providers of big data. Internet, not of things, but the classical internet is obviously a huge provider of big data, but IoT is really contributing that to that quite heavily, right? So interestingly enough, just wanted to tell you that Vint Cerf and Robert Kahn, so essentially next to Tim Berners-Lee, the inventors of the internet, had something like IoT on mind when they started thinking about the internet. So the internet started off with the World Wide Web and essentially became mostly a textual resource when you think about it. Now an image resource also to some extent and numerical resource. But when they were thinking about internet at the beginning, they wanted to think about a network connected to other networks. And they were thinking about something extremely physical. And now, as we're speaking, IoT is developing and really fulfilling sort of that first initial vision that they had on mind when they were starting off, right? So I think IoT is extremely important for all the reasons that we've started speaking about at the very beginning, right? So it's extremely important because it's a driver of change, right? It's a driver of change for AI, but it's also a driver of change for various activities, businesses, products that we can think about, right? Because this real-time data aspect really changes quite a lot in the way we can model behavior, predict behavior, but also design certain services and products for people, right? Here, I love this, actually, this quotation here. The IoT can dive into nooks, crannies, and gaps and wormholes that exist in this imperceptible and often invisible world, right? That extends far beyond human eyes. So it's interesting because on one hand, we can say, and I was showing you wearable technologies that are connecting obviously with, for instance, our bodies to provide information to us. But obviously IoT doesn't have to be towards us. IoT are also different devices that are connecting with one another, even without our intervention, right? So those networks are quite vast, and it's not always human-centric, right? When you think about the factory, actually there are devices connected with other devices and yet with other devices, right? And we only get the final output of their sort of internal communication, and that's something I find very interesting. And you can think also as IoT, and I like this metaphor of tagging, right? When you're tagging physical devices, right, and you're transforming all of them into something completely different, because out of a simple cup, like this one cup of coffee, if there was a little chip here informing me, let's say, how much is left. Obviously, I can see it with my own eyes, so that would be kind of banal. But let's say it's for other types of devices. This information that the coffee is ending here in that cup could be important for the coffee machine that would perhaps send me a request whether I need more or I want a refill, for instance. So that's quite interesting, this tagging, right, process that you transform, like with a magical wand, every device or every object that you wish into a communication object. And that's also a provider of certain deep knowledge, right? Particularly when you think about those factories that I've mentioned, where IoT is most widespread, that's for sure, right? So I think our physical world is not that filled with IoT. Obviously, there are different devices, and that depends also on the place that you're in. Obviously, Asia, China is developing much more into IoT direction. In Europe, for all the different reasons, we are kind of more hesitant. Some devices, you know, are not so well accepted, like cameras in various public spaces, and for many different reasons that makes sense to have a debate how we want them, whether we want them. But it's surely true that particularly in industrial spaces, this is a provision of certain deep knowledge, right? So when you think about maintenance of different devices, when you think about a possibility of preventing a crash, for instance, recently we published an article about wearable technologies in construction sites, right? And where buildings are built, right? For the safety of the people who are there, actually wearable technologies will be key, because if we have information about somebody's condition and that person is high up, right, on the construction site, we want to make sure that this person is fine and that nothing bad happens. If this person starts feeling bad and you have a reading from their smartwatch that shows you that, for instance, they experience a panic attack or there's something else happening, this information can be crucial to actually save their lives, right? So this is, like, let's say, another layer of knowledge that IoT can provide for us, right? So when we think about that, IoT together with the classical internet is actually a huge source of deep knowledge and information, but also a vast field for future explorations, right? When you think even about things like market trends, right? Certain forecasting of the future, right? You have one layer that is very important, which again would be that historical data that you've had, right? Of certain trends happening, but IoT can generate yet another layer of data for exploration, right? So that's definitely something that I think many organizations, many sectors will be looking at. One example here would be logistics, right? In logistics and transportation, real-time data is very important, allows you to forecast how the situation will unfold. Yet another area would be the medical sector, right? In medical sector, wearable technologies are key, right? In telepresence, in telemedicine, in taking care of patients remotely, particularly during the pandemic, we've seen the potential of IoT and how kind of necessary it is, right? And so currently we're talking in the context of IoT about Industry 4.0. Perhaps we will not stop here. Maybe we will talk about Internet 5.0 and Internet 6.0. We will see more devices, more potential happening, but that's definitely a big driver of change that we're currently seeing. And some features of IoT, I think, that are very important are related to providing this next layer of context, right? So, for instance, what IoT, different sensors can do for you is provide location awareness, right? Where are things happening? This is very important, right? That geographical component, very often not present really on the internet. Here with sensors is very granular. On the other hand, option of enhanced situational awareness. what's happening, how many agents are in this situation, right, involved, right? That's a big driver of different kind of analytics, right? When you think about decision making, for instance, for autonomous vehicles, actually autonomous car on its own is a great example of IoT because it's full of sensors of any kinds, right? It has to operate in the real world. Around it are different agents that are going to make decisions to stop, to drive, right, to move on, to break the rules or to stick to the rules. And this car has to react properly to whatever is going on, right? And location awareness, situational awareness will be key to autonomous or semi-autonomous vehicle to actually operate in the external environment, right? So that's really something that is extremely important. And this component, for instance, that I've just mentioned, like in construction site, certain hazards, right? Like in manufacturing, in building facilities, this thanks to IoT can really be omitted, and that's also very, very important. Yet another thing is that those devices are also internally more and more complex. They're getting smarter and smarter. It's not always the same direction that we would perhaps want for them. So sometimes they're getting smarter in a way that is less useful. Sometimes they're getting smarter in a way that's more useful, right? So one way of getting smarter is that you have, let's say, one device that is equipped with many different kinds of sensors and can do many different things for you. And that's the smart phone or smartwatch, essentially, right? Where you have different sensors, camera, gyroscope, location, navigation, all these things kind of bundled up together, right? And these devices do get smarter and it doesn't seem to stop. Yet another thing could be that you have one device that is good at something and over time becomes better at it, right? And the devices that I've been showing you at the very beginning, those wearable technologies, the headband, for instance, that I have shown you, is quite interesting here because actually this headband at the beginning makes quite poor readings because it doesn't calibrate to you well. But over time, it learns about your habits of certain behaviors, that if you sit in this position, you're going to be able to focus much better, right? And when it learns about you, it can provide more personalized guidelines. And it's constructed in such a way to unfold sort of over time. And I think that's very, very interesting. And it is true that connected devices can translate, I think, into connected people, and wearable technologies are a great example here. Another example I could provide for you is a device that we have used at the MIT Center for Collective Intelligence, a sociometric badge, which was as little as this, like very small little device. And this device is something you would carry on your shoulders, right? And what it would capture was, first of all, the volume of the voice people speaking and the turn-taking aspect, right? So we were trying through that, track certain patterns of organization and see whether in a company, the culture is so that everybody speaks up, or is the culture so that only some people speak up? And those who speak up, for instance, shout. Right? And this device is very interesting, but it can be very tricky for organizations that request, the scholars to use it, because it can turn out that, your organizational culture is not the one that you depict, right? Not necessarily as good as you think, because it turns out that the boss at the meeting is always talking and the others are just nodding their heads, right? And that's not an organization that is truly thriving and where everybody feels in place. But a device like that can really tell you quite a lot about that. So you can check it out. It's a pretty interesting type of sensor called the sociometric badge, right? And on MIT, there's a whole section of articles about it, right? So we do think how also these devices will be connecting with one another, and you can see many companies that are trying to somehow push through it, and some of them fail and some of them do a good job. For instance, a talking fridge is not necessarily something you would like, right? I mean, a fridge that talks to you is maybe not the best example of an IoT, but maybe a fridge that sends out information every now and then that is almost empty could make more sense, right? So we've seen how different companies were trying to design the whole process, right? From the shopping list to finding recipes, right? You have that fridge that has all these different functions all of a sudden, right? I mean, tells you information, provides information, even can order something on Amazon, right? That was the attempt as well. And sometimes the design of that process really doesn't take humans into consideration and can fail, but sometimes it's quite interesting. And I think one interesting example of that is, for instance, Alexa, because Alexa can be trained to obviously respond to various queries, and sometimes it does a good job and sometimes it doesn't. But the most interesting application of Alexa is that when it's connected to the smart home, right? So when you have an Alexa that can turn the lights on and off in your house and you just use your voice to make it happen, or when you have an Alexa that's connected to your coffee machine and you tell Alexa, I woke up, I would like my coffee, and then Alexa orders the coffee at the coffee machine, that's actually a pretty interesting flow, right? That could be useful for you during your daily errands when you are running out of time, and you definitely need that. So that's something that I think is very promising. Obviously, there is a question, right? There are many questions that are always related to big data and that we've touched upon very briefly, you know, kind of how to make it ethical, how to make sure that we understand and have a full transparency about the process of that data flow, particularly if it's data about my daily routines and something that is absolutely intimate to me. And that's always the question related to IoT, maybe not in the industrial space, but particularly in relation to wearable devices, right? Such as the devices that I was showing you at the beginning, right? You either had a clear data flow or you don't. And when you don't, you should be more hesitant, right? About the future of this particular device in your household. That's at least my sort of take on it, and that's my observation. But it's absolutely sure that IoT, no matter what, in different spaces, in different ways, at different paces, will be growing, right? And the fact that it will be such a big provider of big data is obviously a certain question, I would say, a certain question. We have to figure out already now how to capture data best, right? And whether the design of these wearable devices allows us to make it happen. For instance, there were some wearable devices that were EEG devices that were not taking into consideration that your forehead is going to sweat. And therefore, after half an hour of usage, they were absolutely useless, right? So how to capture data best, how to store that data, right? In the cloud, most probably, right? But in the best and safest way, and how to analyze that data. And here, obviously, AI, machine learning will become a very, very important kind of toolkit for that. So I do think that various traditional infrastructures that we've had for data collecting may not accommodate even the flow of data that will be streaming, right? Because IoT is growing every day. The internet is growing every day, but IoT is also growing very, very significantly. And we need new infrastructures and new data pipelines that can really accommodate this huge flow of data. So to make sense of that data, right? And create, I would say, businesses, processes that are actually going to serve someone in the best possible way. And also extract this context that is most relevant to make decisions that are going to be good for us. And okay, yet another example, obviously, and I'd say another frontier that I would be very happy to observe, or that would be very interesting for me, is obviously smart houses, smart buildings, and smart cities. And here IoT can play a role that is not only consumer-oriented or, for that matter, profit-oriented, right, for companies, but also related to sustainability, right? There is a promise that with IoT, with certain granular information, we can create more energy efficient buildings that are going to be more sustainable, that we can create cities with less smog and less traffic, right? And through that actually achieve perhaps somehow better scenarios of the future that is more sustainable. And I think that's another very important promise of IoT. And that's a use case of IoT that is, I think, most demanded currently by everyone. And I would just very briefly, because that's I've been speaking for quite a long time, and I know that you may have some questions, and I obviously encourage you to ask them. I'd just say that perhaps it would be also advisable for those of you who would like to dig deeper into IoT to take a look at various ways to analyze big data coming from IoT, There are many different systems that are capable of doing that. One very interesting system for analyzing big volumes of data also coming from sensors is MapReduce. It's a certain data processing system, which is the core of Hadoop, really, and used by various companies such as Facebook, Google, or Amazon. And it's a way to process a kind of data that is very distributed. It has sort of two components, the mapping components and the reducing component, as the name sort of says. And what it does, it takes a data set and converts it into another simpler data set that is easier to digest, and then kind of reconnects all the information that was broken down together. So here you see some steps: the map component, the shuffle, which is the grouping of data, and then reduction component, which kind of congests that data into clusters that are sort of easier to manipulate. And here you can see one very simple example, right? How the so you, let's say, put a certain input or throw certain input that's get splitted, right, and then mapped, and then reshuffled, reduced up to a final output, right? And that's a very simple way to process big data, in particular big data that comes from sensors. There is a nice tutorial for those of you who are more inclined to program. I'm just gonna send out the presentation after our conversation today, and you'll be able to perhaps try it on your own. If you have any basic skill set, right, in SQL or something, perhaps that will be something that you would like to do. There are many freely available data sets with sensor data out there. So for more technical people, I think it can be a nice ride. And one more thing I would show you is just a highlight of one interesting technique that allows us again to manage and map sort of big data coming from sensors is a Bloom filter, right? And the basic idea behind it is that even in a huge, vast space of sensor data, you can always ask a question of whether a certain item that you need or you're looking for is in that data set, is in the list. And that's very relevant information for maintenance, also for prediction of certain events, for instance, crashes unfolding. And Bloom filter is particularly good here. And I'm not going to go into the details of explaining that, but I would perhaps just show you that there is a nice tutorial on Bloom filters on GitHub that you can take a look at. It's very simple. It works like this. You have a whole explanation of how that works. You don't have to understand on the details, but I think when it starts to work, you'll get a gist of that, right? That you are looking, let's say, for a certain element in a certain array, or you are trying to place, let's say, or to find certain elements in a big array of data. It can be huge, it can be very, very vast. And you add it to the Bloom filters, and then it reserves space for that. And then again, reserve space for another element, yet another one. But then if I come back to one, it's going to show me where that one was in the first place, right? And so it hashes all the information in the proper places. And then afterwards, when you need them, it's going to be immediately found for you, right? So that's kind of interesting. But that's just for the analytics to show you that there are plenty of algorithms, plenty of different ways to analyze the data coming from sensors. And also, some of them are very classical, like Bloom filters or MapReduce, but some of them are very advanced, and they are related to artificial intelligence. And obviously, we will talk about them also on Friday, but very briefly. All right, with that, I would finish off perhaps the presentation part, and happy to take or answer any of your questions that you may have related to IoT. Thank you.
Thank you so much, Alexandra. Fantastic presentation and making it easy, I think, for everybody to understand, and also keeping some exciting parts for the very end for those who are technically more inclined or advanced to test it out. So we are a small group, so if you have a question, then just raise your hand. It would be nice to see you for those who have a question, if possible. Maybe I start with the first two questions. To warm up, and then I'll invite our teachers to join. So my first question is a personal to you, Alexandra. You do not use a background screen showing a robot behind you, but we see parts of the home. So maybe you can share with us what IoT technology device you are using at home, what is really essential and what is a nice to have. So that's my personal question first.
Well, that's a great question. I mean, we mainly have different types of toys that are essentially IoT carriers, I would say. So we have plenty of little robots that I'm not probably going to show now, but I can show one of them when we meet next time. On Friday, we have the so-called hex bugs, which are little like cockroaches that run around and they are afraid of light and also of sounds that are extremely loud. So if you yell at them, they're going to run under the couch. And that's something that our daughter is often testing. It's like hexbugs are a nice, I would say, imitation of how of certain basic features that allow for survival. And that's why I find them kind of interesting as entities, let's say robotic entities that respond to natural stimuli like loudness or like the light. So this is something I've been showing to our daughter. Obviously, you know, plenty of different devices that are classical, laptops, tablets, and other things. And we also have an Alexa, I'm going to admit that, but I'm not turning Alexa on quite often, only every now and then to check how it has evolved over time. Sometimes my daughter uses Alexa to as a storyteller in English because that's her second language. So sometimes she wants to hear jokes or like stories and kind of interacts with Alexa as a virtual assistant at home. But like, I mean, I am not a person who would turn on all these devices all the time, but rather choose moments when it's right to use them and certain, you know, pathways to use them. So apart from that, I'd say that I also have obviously 2 smartwatches. I have 17 headbands in my house. But most of them I use for my lab. So those headbands that I was showing, the Muse headbands, this is something we use quite often. And so I have mostly, you know, most of them in my house. So when I count, I think my house is full of IoT devices, but some of them are very peculiar.
Thank you so much. I have to say, we also have an Alexa at home and sometimes have to be careful because the kids love to do mathematics homework with Alexa. Works brilliantly because she has most of the time the answers, at least to the simple questions. Then my second question, while we are still waiting for the chat, a teacher to ask is, in a school environment, what do you think are here devices which are ethically reasonable and not? I mean, you earlier mentioned the technology to measure boredom. Probably that's exciting for teachers to know when is the moment when I lost all of them. Probably more important in online meetings because you don't even have the physical expression that much. But what do you think, and maybe you can share a little bit also what, because you highlighted that in an Asian context, the cultures of society are much more open to that. Why is that so compared to Europe, where we are a bit more resistant?
Well, sure. So I'm going to share European perspective because obviously I'm from here. Obviously, there are questions related to privacy of certain data. And, you know, I guess the level of intervention you may have. So I do know that, for instance, in some Chinese classrooms, there were pilot projects related to attention of children, right? And I understand that the purpose of that can be very much research oriented in the sense that you want to understand whether what you're doing is a good job, right? Whether the students are fine. But obviously, on the other hand, there can be always I would say a hesitancy of, you know, how that data is going to be used. And I can just give you an example of this device that we have used, Muse headband. Obviously, we've used it in a lab setting, so sort of for a scientific experiment. But on the other hand, I do remember a question that somebody posed on a group chat related to this device. And there was like, oh, my boss is inclining everyone to wear these headbands and to have sessions of focus, collective sessions of focus together. But I am afraid that he's going to look at my readings and be unhappy with how focused I was. And then it's going to use that data against me, right? So I think that's a valid point. And sort of, I don't think that particularly with children, you have to be very, you know, you have to be really sensitive to all that stuff, especially that, the focus with children flows many different ways. This doesn't have to be reliable information, not necessarily information that you should be sticking to in terms of like figuring out what to do next. I think interaction with real people and asking them questions is here a much better solution. But I do see a lot of good examples of the usage of IoT at schools. For instance, I remember Google Cardboard, which costs only like $5, is a very interesting sort of VR, right? Kind of a setup, and it's very inexpensive. It's actually eco-friendly. And I do remember I saw like a class that was a biology class about dinosaurs, and the kids could look through the Google Cardboard and actually see how big the dinosaur was, in the cardboard, because the dinosaur was right in front of them in the class setting. And that made the class very, very entertaining. And it's not to say, again, that we should all just go to VR, but perhaps there are certain pathways that we could explore how to include such devices in our teaching practices, because for students, it can be extremely entertaining and very, very interesting, right? To see real sizes of something, or to see a liver, to see lungs, right? To see something actually, as a visualization that kind of exists as a 3D object. So I find that very interesting. I also have to say that this area of combining programming with physical objects is very interesting. So all types of Lego blocks that are sort of programmable, right? So that's very interesting. And let me just show you one thing, because I just remembered that I have it here. Oh, did my daughter just take it somewhere? I wanted to show you a set of devices that actually works a bit like Lego, but this I can't find it now. But so one thing I would perhaps show is, oh yeah, I have it. Sorry, I'm just going to show you. So one thing is this, right? A device that you can program that actually works in a real setting. I find these to be very interesting, devices like that the child builds and then executes certain functions and then learns programming and learns how these two layers, the digital and the physical, are connected. And a super cool thing, and that's not an advertisement, I'm just, showing you like random stuff, is this little bits. So these are like circuits, right, that you can connect with one another, and that's going to cause effects like loud sounds or movement, or it's going to trigger them in a different way depending on how you connect them with one another, right? So there's a whole set here, and you can connect the strings in many different ways. It looks like this, very friendly, but also very engineering type, right? So it's not like too dolly, kind of too sweet. It's actually like a real set of engineering devices. There are wires, there are different types of buttons here. There's a LED light, there's, a buzzer and other components. And that kind of teaches you the basics of let's say, of engineering. And at the same time, you can generate a device here that's going to, let's say, to connect with your phone and then cause the phone to ring, for instance. So that's like interesting, and that's basics of IoT for children, which I think is really cool. And then you can take it to the next levels. Obviously, this is for beginners, but later on, and also if somebody starts that journey a bit later in life, that's going to be as extremely entertaining as well. So everything that's really connecting the physicality, the real life, with information processing, I think is of value, because we tend to think very often about internet as something virtual, but IoT is different. IoT is the real life.
Thanks so much, Alexandra. Really exciting. Also nice to see how we had a conference a few years ago about gender equality and STEM. So I definitely, at your place in your family, the girl starts early also to
yeah, programming is important in our life. I have to say, programming is important. And if I could just say one more thing, Leonie, because you reminded me of something. There are special programming applications for girls. There, one of them is called Imagilabs, and if I may, I'm going to write that on our chat, Imagilabs, because this is kind of a Python programming platform that allows you to build jewelry physical objects, right? Again, so like, I mean, they are not going to be objects with devices. They're not going to be connected objects. However, there is again this layer of physical product that comes out of your programming practice. And I find it to be extremely entertaining. And my daughter, who is programming from the day she turned 5, I would say 4 or 5, is really into doing that stuff. She's not a passive consumer of technology, rather the creator. And this is kind of the spirit that I think is worthy in education.
Thank you. I saw Jyoti raised her hand, but I first,
yes.
Sorry, give the floor to our teachers. If anybody of our teachers would like to ask a question, please. Or David, yes, David Krelin, Alexandra, he's coming also from the tech side. He's our partner in the Visegrad project. David, if you want to ask a question, of course, please also go ahead.
We have a student from participant. From Dr. Haider Nasser from Hungary. So, so he's asking, which devices do you recommend that can be useful and available for students in school?
Well, as said before, various types of inexpensive VR, I think, is very, very interesting, right? But I'd say that also different types of smartwatches, right? Where students, for instance, could perform certain coordination experiments, who is where, right? I mean, finding one another, group dynamics. There are many watches that are absolutely inexpensive that the school, I'd say, could purchase, and then you can build apps for these watches, and the students can do many things, like, for instance, survey one another, right? Are you happy? Are you not? Where are you? So I saw some experiments like that in school settings, also in the US. That was interesting. And obviously, I'd say everything related to Lego bricks, all different types of bricks that can be connected with one another to create an effect of a device that sends information to another device. That's always like something particularly for early school children that I'm not a teacher, I'm teaching students, so old people, like old, obviously older adults, but like that's something I have seen as very operational, and I find that to be a great example of IoT.
Thank you. Another question from our teachers?
We don't have any so far. Maybe I can ask one in the meantime.
You can ask, Joy. Yeah. And we have Agnieszka. I think we have Agnieszka asking a question here.
Okay.
Okay. As all those IoTs collect video, sound, etc., how can we be sure that it's safe and secure? Yes, that all those collected data is not going to be used against us later.
That's a great question.
Yes, there are many devices that can behave like, there is a question of all those devices like being some kind of a spy, yes, around our house.
Yeah, absolutely. Thank you, Agnieszka, for this question. I fully agree with you, and this ethical component is something that needs to be highlighted. That's why I would always recommend actually buying devices that are recommended for schools or recommended in scientific usage, because over there you will always have a protocol of, for instance, switching off the flow of data to external parties, right? You will not get that with a Fitbit or any other consumer technology, because they actually rely on data. That's their business model. They're going to sell that data rather than not. But with a device like this Muse headband, for instance, that is essentially mainly for, you know, for research usage, but also for therapy, kind of the application allows you to select how you would like the data to be retrieved, right? I mean, where do you want the data to land, whether you want to be informed, whether you want to switch that off. This is something, and unfortunately, that also requires your attention as a teacher. You will have to take care of that. There are no guaranteed procedures here. I would just say that usually something that is explored in a lab setting is going to be much safer. It's going to be kind of ethical. Open source communities usually produce also devices that are, there are many open source groups that are building different wearable technologies, sometimes even give them away for free. And here this I would say the standard code of working with data is also very ethical. But for like, if you decide to buy a set of Fitbits or like other Pebbles and others to a class, obviously you will have to put extra attention to actually hack the system a bit and disable that functionality if you don't want to send that data anywhere else. And it's not like an easy job, definitely not an easy task to navigate.
Thank you for the answer.
Yeah, it is what it is.
Do we have any more questions from the teachers? You can either raise your hand or you can just start speaking up. I don't see any, so maybe they are thinking of
okay.
questions. So I'm actually a bit curious to know on a daily basis, if we are wearing like a IoT device, for example, I'm wearing a Fitbit, we of course know that we are contributing to the development of IoT devices and the data, but are there like situations where we are unknowingly contributing to the development of IoT devices? And
of course.
yeah, and then another question that's related to this is like, we see that the IoT devices are growing and it's everywhere today. Will it have any challenges in the future, or are there any implications, positive or negative?
Well, I mean, now to your second question, obviously there are technical challenges with not maybe storing that data, but processing it. Huge volumes of data. If it's true that all of us by, I don't know, 2025 will have, let's say, per person, 8 IoT devices or more, then, you can only imagine how much of a data stream that actually is. So really analyzing that data is going to be technologically challenged. That's one of the challenges. But there are many other challenges. Those challenges that were raised, for instance, by Agnieszka, the ethical challenges, right? Codes of conduct, certain best practices on how to anonymize data, pseudonymize data, so that we actually all feel safe, and possibility for us to always request information on where the data lands. I think, this privacy by design rule is something that I'm not sure if it's going to be implemented, for instance, in the European Union, but it's definitely like something that I think many consumers would welcome to feel safer about IoT. And now to your first question, the question about the different devices and whether you're contributing, right? I think you're constantly contributing in a way that you don't fully understand, because, for instance, I quite often don't know, right? Exactly, maybe I do know which data is stored or which data is retrieved or captured, but I don't know where it goes, right? So even though, when I'm using a wearable technology, I can understand well that the data that is retrieved there comes from the involuntary movement of my muscles here on the forehead, and that's fine. I understand that this part is getting processed, and I kind of even know the technique with which it's processed, or I can presume which technique that is. I still do not know how many intermediaries are on the way, right? And who's going to make use of that, and where and how exactly. So I do think that we are involuntarily contributing constantly, or like even stuff that you don't think about. For instance, currently, there are so many attempts to create smart stores, right? Stores with shelves. On the shelves, you have sensors, right? And that sensor is tracking whether certain products are vanishing from the store or like not so well bought by consumers. So every of your consumer decisions is actually fueling IoT if you are in a store like that. In Poland, we have a few different companies that are testing that for sure already now. Not only like a store without cashiers where everything is digital, but even like a classical store that looks very typically, but does have sensors on the shelves that analyze constantly the information of which products are disappearing. So I think your contribution is very vast and sometimes very hard to navigate.
Thank you so much, Alexandra. If no more questions, we know that you are on the way, not to the moon yet, NASA, and need some time to prepare. But we are having a group exercise prepared when we dig a little bit deeper into the questions of what IoT devices our teachers have either at home or maybe even at school. We are really happy to see you in a few days again on the.
Oh, I see. I see. We have one more question. Sorry, I'm just going to perhaps answer that because we have Dr. Haider Nasser from Hungary. To everyone, what do you think about the future of smart cities and houses? Well, that's a big question. With smart homes, I think that with the pressure on sustainability, we will see more of that. Maybe not in the context of a smart home from the Jetsons movie, where everything is really served to you and you are, you know, in a fully automated house that opens the doors and everything. But in terms of trackers that track, you know, for instance, carbon footprint, that track energy consumption, we will see more of that. That, for me, that's for sure. I see investments in such infrastructure already now in Europe quite widely. In terms of smart cities, again, they are becoming smarter. You have cities like Amsterdam that they have extremely ambitious smart city agenda, right? Tracking recycling procedures, tracking whether people are sticking to recycling, tracking movement, tracking everything. You have some cities that are more cautious about that. You have people who are rebellious against, for instance, cameras in the city space. So that's a turbulent space. But, you know, we already have pioneering cities, quite a few in Europe, quite a few in the US that are definitely becoming smarter and smarter. It's not easy to see, but definitely it's progressing. So I would just perhaps leave it here, Leonie. Sorry for disturbing you, but I just saw the question, so decided to answer somehow.
No. I'm happy that Dr. Haider was raising it, and we had another question from the teachers on the topic of smart cities. We actually currently run another project on sustainable urbanization, and I just want to highlight here one part which was emphasized in that project. It's not about smart cities, it's about learning cities. So we can be as smart as we want if the learning is not there from the bottom to the top. And usually smart cities are, and that's the critique towards that, is something which is very much or very often delegated or planned from the top to the bottom, but it doesn't reach actually, or it doesn't achieve a very participatory approach and an inclusive approach. And that's something, we can have all these technologies. If we don't know how to use them, if we don't learn how to use them, they are not really useful for us at all. So that brings us to that part, the end of that part of the session today with Professor Jalinska. So all the best for your conference now. And
thank you so much. See you Friday.
On Friday, exactly. Thank you so much.
Take care. Bye.
Thank you.
Okay, wonderful. That was a good start. Solid presentation with all the core content. If you want to dig deeper, I mean, we share with you the slides, and you can look into the programs, the links Alexandra has shared with us. Jyoti, can I ask you or Angie to go back to our PPT? We have a small exercise for you, which I think we can probably do in about 10 minutes. So we are finishing our session as planned at 9 in Singapore time, 9 o'clock, at your time, 3 o'clock. Jyoti, do you want to explain the exercise?
Yes. Okay, so now that you got a lot of interesting information about Internet of Things, we want you to take part in a self-reflection exercise, and we also hope that while you are participating in this self-reflection exercise in teams, you get to also bond with each other a bit. So, so we want you to find the IoT devices that are around us. They are everywhere, as Professor Alexandra mentioned. And we want you to look at two different areas. The first one is in your school environment, and the other one is in your home environment. So I will share the Google Slides in the chat box later. But just to give you some guidelines, at first, we will assign you in two different breakout rooms. So when you go to your breakout room, just look at the number of the room, whether it's breakout room 1 or 2, we will have 2. And then if it's 1, then you click on the link for team 1, the link for the Google Slides. And then when you were already in breakout room, you found your Google slide, and then nominate somebody from your team who can type down, because if everybody's typing, there might be overlaps and things might get deleted. So maybe one person can type the notes, and then select another person so that everybody get to speak and take part in something to present the list that you have created. And then we'll give you 15 minutes, but if you are done within 10 minutes, that's fantastic. So let's see. And yeah, and then we'll have, after this, we'll have a very brief presentation on the notes you have taken by you. So let me share the first two links in the chat first before we go to breakout room, but we will also visit the breakout room just in case, and then we can. Okay. So before I go to breakout rooms, do you have any questions regarding the exercise? Do we need to clarify anything? Is everybody on the same page? No.
Silence means no news. Good news seems clear.
Okay, then we go to breakout rooms.
So welcome back. Also nice to see you. A few more cameras are on. That's always good. And we start with the group number 1. Who was the volunteer or the mandatory volunteered person who will share with us what kind of IoT devices you have found in your different homes, and what is obvious as an IoT device recognizable in school. Maybe there are some more which are not known yet. Team number 1.
Hello. I was chosen.
Okay, good. You're the volunteer today.
One.
You're the chosen one. It sounds much better than volunteer. That's true. Okay.
We have this discussion about Arduino. As the teachers, we were, me and one of my colleague, programming with Arduino. That's programmable microcontroller for weather station and monitoring of voda po anglicky sa jak povie. I need translator, sorry.
Okay, maybe somebody of the team, just say it in your own language and maybe somebody can translate it from the big group.
I have it in 1 second, please. Soil, that was the word.
Yes.
Soil monitoring.
Yes, soil monitoring and irrigating system by the connecting with phone and with some system who control the humidity of soil.
That's great. Then smart fridge, smart glasses, car, it's full of sensors. My friend have a 3D printer. This can be used in school. Then smartwatch, smartphone, city security systems is now very popular to build. Navigation system, and the irrigation at the garden and automatic blinds at home.
Great, that's fantastic. So absolutely curious to see the garden of the person, because that one probably is just flourishing and blooming all the time thanks to the good watering. Who is the one who has a smart fridge, out of curiosity and for a little bit of fun sharing? What is your fridge? Are you checking if your fridge is empty or open, or is, as Alexandra said, is it talking to you? Who is the one with the smart fridge?
It was Alexandra. I don't know.
Alicia.
Is the person still with us? Or was it more a wish list? Maybe it was more a wish list.
Christmas is coming soon.
It's coming soon. Okay, good.
Mhm.
Then maybe we go. Thank you so much, Peter, for sharing. Maybe then we go to the second group.
Okay, thank you.
It would be interesting to see if we include your students, if your students would have added a few more devices and which they either have in school, probably not in school, but rather at home.
You know, we started with the list connected with our home IoT devices, and we thought that we will make a list of IoT at school later. But let's start with the second slide, IoT at home. It's obvious that almost everyone, almost all of us in a group have got smart TVs at home that are connected to the internet. Because nowadays, fewer and fewer people watch television. We just enter the internet, watch YouTube. We are connected with connected to Netflix, HBO. We do not use television anymore, at least me. Smart fridge. I haven't got one, but as you've said before, it's our maybe our dream to have one. Yes, something that we would like to have on our wishing list. Smartwatch. For me, this is something I can't live without because I run half marathons and marathons. So I need to have one connected to the mobile phone to collect all the data. It's got GPS. I can store some music connected to the headphones. Food processor, Thermomix. This is something I can't live without as well. While I'm working, it's cooking for me and for my family. It saves time. I recommend everyone to have one. Smart cars. This is something typical of men. So maybe let's ask the rest of the group. I haven't got a smart car. Yes, I've got a car that is old. And the only thing it has to do for me is just transport me from A to B point, and I don't need any other functions to have. Smart bicycle. We haven't understood the question. We thought that we need to put on the list everything that comes to our mind, and we weren't sure if it is going to be something that we have at home. In fact, that's why we've just taken down a smart bicycle as well. As for the school, we haven't finished the list, but these are smart televisions, digital overhead projectors connected to interactive whiteboards, smart televisions, interactive whiteboards.
Edit the spelling later.
I don't know. Anything else? The radio, CCTV. I'm not sure if it is connected to the internet. Yes, it must be connected to the internet. Someone needs to check what's happening around, yes, and can enter and watch what's happening around the school. So CCTV, I don't know. In 2 days, we're going to have a weather station as well.
Wonderful, Agnieszka. That is, you just took the words out of my mouth, because this was
I was waiting for that too.
my concluding sentence for today, that even if
this is going to be the most innovative one.
And that is your Thermomix, which is probably not telling you the food is ready.
Sorry, I needed to open the door.
I was joking. I was joking. I was saying that was probably the Thermomix which gave a signal that the food is ready.
No, That was the
doorbell.
Yeah.
Okay, so thank you so much, Agnieszka, and your group for sharing. Yes, the weather station will be the new additional IoT device, which you will all have. And it's on its way being shipped, and hopefully it will arrive, if not this week, then next week, and you can test it out. Okay. With this little summary, there are obviously, I think if you would ask you this question in 1 year or 2 years or 3 years, you probably will not stop typing, because so many different items will come.
Yes, the list would be much longer.
Exactly, it will exponentially grow, but it's a good start with all of us, or for all of us. From our side, thank you so much for being here with us. We have Alexandra again on Friday. I'm not sure if she will update us on the NASA conference, but she will give us an update on AI in general, and we'll do a little exercise again on that. Hopefully all of you will be with us. Bring your students as well. You've realized Alexandra is very hands-on and shares also some practical examples with you and hopefully with your students. The timing remains the same, as just that the date has changed, because she was not able to be with us on a Wednesday. That's why it's on a Friday. So we wish you a good night from Singapore, and until the end of this week.